This is the 6-5 video on diagonals in 2 dimensions using everybody's favorite formula, the Pythagorean theorem. Now before this instructional video continues, make sure you have your notebook and a straight edge and graph paper at your desk. If you do not have graph paper now, please go to the student supplies cabinet and grab a sheet of graph paper. As promised, you'll need graph paper. So pause the video and take a moment to label the coordinates of the parallelogram A, B, C, and D. So go ahead, plot those 4 points on a piece of graph paper. Press pause while you're doing this. All right, ladies and gentlemen, your parallelogram should look just like mine. You should have A, B, C, D here. So that's my parallelogram. You should have plotted those points and connected the points with a straight edge. So what we need to do here now is we need to calculate, the point of our lesson today is to calculate the diagonals of this parallelogram. So the diagonals are going to look like this. From A to C, that'll be one diagonal, and B to D. Now in an earlier lesson, we calculated the distance between 2 points on a coordinate plane by essentially creating a right triangle. So that's exactly what we need to do now. Right now, I can, in my mind, maybe forget about the parallelogram, and what I need to do is I need to draw a right triangle going from point A to point C. Now bear with me here on my iPad. I cannot use a straight edge. So that's going to be my diagonal. Now from here I need to create a right triangle out of this. So I think what I'm going to do is go down here and over there, creating my right triangle. I could also go up and down here. That would also work. So I'm just going to continue this and draw my right angle. And again, I'm going to apologize because on my iPad, the device that I'm using to record this, I can't use a perfect straight edge. So diagonal is line segment AC. That'll be my diagonal 1. Jot this down in your notebook, please. I'm going to use the formula A squared plus B squared equals C squared. So what I'm going to need to do here is I'm going to need to calculate the distance or the length of both of those sides. So if I count up from A is 1, 2, 3, 4, 5, 6 units high, and it should be 8 units long this way. So I'm going to put an 8 there. So I'm going to do 6 squared plus 8 squared. I'm calculating for my C squared, my hypotenuse. So I'll get 36 plus 64 equals C squared. I find the sum of 36 and 64, that's 100, equals C squared. And then again, to get C, I take the square root of both sides. So 10 units, that is my mistake there. Square root of 100 is 10. 10 units is my C. That's supposed to be a U there for unit. So line segment, or I should say diagonal AC, is equal to 10 units. All right, now you might think that line segment BD would be the same measurement, but if you look at it, it appears to be a little bit longer, just visually. So I know it can't be exactly equal to 10. So what I'm going to do is I'm going to go ahead and draw my right triangle. This time I'm going to go up, just to hopefully make it a little bit easier to see. I'm going to draw in my right angle. And when I do my calculations, this side right here measures 6 units. And my top, my longest side up here, measures 16 units. So again, I'm going to go over diagonal, let's see here, BD. I'm going to calculate that by going, again, A squared plus B squared equals C squared. So I'm going to get 6 squared plus 16 squared equals C squared. All right. Then from there, I'm going to get 36 plus 256 equals C squared. The sum of those two numbers is 292 equals c squared. And then, of course, I take the square root of both sides. So I'll get about 17.09 units equals c. So line segment BD is equal to about 17.09 units. And again, one more time to get that, what I need to do is I need to take my parallelogram, which is originally graphed, and turn the diagonals into two hypotenuses and create right triangles around them and use the Pythagorean theorem to calculate those distances. All right, here's our next example. In this example, you have to calculate the total area of this triangle and this square. So here's a heads up, guys. You're going to want to make sure that you look up in your math book or in your planner formulas for area of several shapes. Triangle, square, rectangle, parallelogram, trapezoid, circles, to name a few. So we expect that in 8th grade you know these formulas off the top of your head. We will have no problem putting a problem similar to this on a test or quiz and expecting you just to know the formulas of the area without having to look them up. So right now we're going to talk about the area of a triangle and the area of a square. So in order to calculate the area of a triangle, you need to know that the area of a triangle is 1/2 times the base times the height. So I'm going to go over here to the triangle that I'm given. Here's the height of my triangle. Here's the base of my triangle. And I want to point out, I don't have a measurement for the base. So I need to calculate the area of this base. Okay, and I can do that because I can see it's a right triangle by using a squared plus b squared equals c squared, the Pythagorean theorem. So what I want you to do right now is I want you to pause the video. I'm going to plug in b here. And I want you to calculate the length of b. So pause the video and do your work in your notebook. Hit play when you've calculated the length of b. All right, ladies and gentlemen, I took the time to label my work. I put base of a triangle. I used a squared plus b squared equals c squared. I showed every single line of work, and I ended up with b equals 4. Now, b equals 4, that's just the base of my triangle. What I need to calculate is the area. So knowing the height, so over here, knowing the height, and now I have my base, I can plug base and height into this basic formula. So the area of the triangle is 1/2 times the base, which we just calculated to be 4, times the height. All right, I put 5, but the base is, or the height is really 3. That was my mistake. So my area of the triangle is 1/2 times 4, which is 2. 2 times 3 is 6 square centimeters. My centimeter doesn't want to turn out there. So the area of the triangle is 6 centimeters. Now I'm going to put a box around that so I don't lose that work. It tells me to find the total area, not just the area of the triangle. And the other clue or the other hint they tell me is that this shape is a square. So what do I know about a square? I know that all sides measure exactly the same unit. So all of these sides are not 6, as I'm writing. All of these sides are 4, because I just calculated this base to be a 4. Okay, so now I need to calculate the area of the square. So the area of the square is side times side, or side squared. So the area of the square is 4 times 4, which is 16 square units. All right, I'm going to put a box around that. That is still not my final answer. So if I go back up to the directions say find the total area. Total means I have to add. So basically what I'm going to have to do here is I'm going to have to add the area of the triangle, which we decided was 6 square centimeters, plus the area of the square, which was 16 square centimeters. and that's going to equal 22 square centimeters. And I need to label this as total area. And you're going to want to do this on your test and quiz because there's a huge margin for making a mistake here. So what you're going to want to do is you're going to want to take the time to show us where you're calculating the base of the triangle, or maybe it's the diameter of the circle or the diameter of a rectangle. You're labeling the area of the triangle. You're labeling the area of the square, and then go ahead, make sure you label the total area so we know that you know what the final answer is. All right, ladies and gentlemen, you know what time it is. It's checkpoint time. So go ahead, press pause on your video, jot these 2 problems down in your notebook. Before you put your computer away, make sure you check in with your teacher. If both answers are right, you will earn your homework for today. Again, I want to stress it's really important that you do these on your own.